So I'm just going to start with this hypothetical. I have this double integral 3x minus 3y dA where my region is bound. And I hope this is clear about what how I want to set up my dy dx and how I set up my bounds. Because right now I only see 3 bounds and that gives me a bit of an issue. So I sketch these things here. All right, this line is here, this line is there, and I definitely am looking at this region. Because x equals 0 is here, y equals x, y equals 2 minus x. So I want this region, and I want, just like in Calc AB, I want to go from the start from the same line and end on the same line. So I want to do these. Because had I chosen the other way, somewhere in here, I would have to switch. This is between x equals 0 and this thing. Then it becomes x equals 0 and this line. So I want my bounds to stay consistent. I want my lines to start and end at the same lines every time. So every time I'm starting at 2 minus x, every time I'm ending at y equals x. So that means 2 minus x is my top, and plane x is my bottom. That means if I had my bounds on my integrals, my inner bound would be from y equals x to y equals 2 minus x. And then my outer bound, I notice it deals with x. And I have to set it between two constants. Well, I know the lower bound is what we found over here, that x equals 0. But the upper bound is this moment. So I have to find where these two lines are equal to each other, or they intersect, to then find, hey, that will be my final x coordinate. So I set these equal to each other. This is equal to y, that's equal to y. So I'll substitute this up here. X equals 2 minus x. 2x equals 2, x equals 1, and I know that if x equals 1, y equals 1. So my bounds go from x equals 0 here till x equals 1. And along that, I'm going to continue to add up these for, again, 3x minus 3y dy dx. And that's how I set up my bounds. Now, what if I change my region just a small amount? What if instead of the left side of this triangle, I said instead of being bound by x equals 0 originally, I said it was bound by y equals 0. Well, y equals 0 is this horizontal down here at the bottom. So I'm now talking about this region. Well, again, if I want to stay consistent, I see that by doing vertical stripes, I'm going to run into an issue. So I'm going to start with horizontal stripes. And just as a rule of thumb, if you're doing horizontal stripes, that means dx will be on the inside and dy will be on the outside. Because dx will be from function to function and dy will be from constant to constant. Whereas our original bound, we started with these vertical stripes, which matches up with the y-axis, and so I do dy first, function to function, then dx, constant to constant. That's the trick to remember. As you're drawing these lines, your inner integral will always match the parallel axis. So I know I'm doing a dx dy, but my problem is my lines here, the first line, I can swap to be x-centric, call it x equals y, but the other one, I do have a little bit of algebra to flip this thing to be x equals. I'd have y minus 2 is negative x equals 2 minus y. And so once again, I'm thinking which one is higher, which one is lower. Because I'm thinking along this axis, it's actually further right is higher, further left is lower. So I would have 2 minus y being my upper bound for x, and plane y being my lower bound. Slap these into my double integral. and I'll be pretty happy. X equals y as my lower bound, x equals 2 minus y as my upper bound. Then I would have my integrand unchanged, 3x minus 3y dx. dy, I know my y needs constants as bounds, and I see my lowest y value is 0. My highest y value is 1. So my y bounds will go from 0 to 1, and now I am set to integrate. And this is true for all of these regions. I mean, they will give you all sorts of different things. Just, worst case scenario, start setting z equal to 0, find your xy plane, and start doing this same work. Good luck out there.